Well, Uranus and Neptune are a lot smaller than Saturn and Jupiter. However, they're pretty much the same thing. You've got some sort of core, some sort of slushy hydrogen mantle, and then some sort of hydrogen atmosphere. Because they're smaller, both in size and in mass, they have a lower gravity. Okay? And we even think that these two might have a bit more of a rocky core rather than just like an ice core. Um, Again, not entirely sure, but that's the going theory right now. They do both have electric fields, and again, that's probably due to the mantle being a slushy hydrogen that acts as a metal that's spinning around. These two planets have a higher density than Saturn and Jupiter, which is why we think that it might have a bit more of a rocky core rather than just an ice core. Now, just because it doesn't mean they're small, right? The cores are still 10 times the size of that of Earth, so still huge planets, but smaller than their counterparts. Their magnetic fields are a little bit strange. They're very strong, much stronger than Earth's, obviously much weaker than Jupiter's. However, their axes are a bit off, right? If you look at these pictures, it's kind of a bummer being online, so I can't really point it out to you, but you can see where the equator should be. And so the axes of your magnetic field should be exactly opposite of that, right? However, your magnetic field is kind of off kilter for that. And then if you look at Neptune, it's the same thing, right? Equator, and then it should be 90 degrees from the equator, and it's not, it's 47 degrees off. So 59, 47, that's a big jump when you're talking about one pole to the other. Alright, so I had mentioned that Neptune, we think there's an internal heating source. Uranus, there's no internal heating source. Whatever radiation is received is given off. It's got a perfect budget. Okay. However, Neptune gives off almost 3 times more than it receives. The only thing we can come up with is that the extra 1% of methane insulates the planet.